Today, we're going to dig into something pretty incredible. It's a secret rule book that, believe it or not, shapes the modern world. It's the document that governs this hidden city of pipes and cables right under our feet, and I'm willing to bet you've never even heard of it.
You know, we talk all the time about being online or working in the cloud, right? But have you ever really stopped to think about the actual physical stuff that makes it all possible? It's not magic. It's a massive, hidden world of engineering.
So our guide to this hidden world is this document right here, SAES-T-911. Now I know what you're thinking. It looks like just a 77-page engineering standard for underground pipes. But trust me, this thing is a masterclass in how to build for the future. We've gone through it and pulled out 5 key rules that make it all work.
And the very first principle we're going to talk about is, well, it's absolutely mind-blowing. Let's call it rule number 1, the 100-year plan. And yes, it is all about building for a future that most of us are never, ever going to see.
I mean, the sheer ambition here is just staggering. The standard says it right there in black and white that these systems are designed to be in service for 75 to 100 years. Just think about that for a second. That's some incredible foresight.
Let that number really sink in. 100 years. They're not just building for next year's tech. They're building for technology that hasn't even been dreamed up yet.
So, how in the world do you actually plan for a whole century? Well, it's a huge shift in thinking. Instead of just designing for what we need right now, they are required, mandated, to build for what they call expected ultimate growth, and to leave dedicated space for repairs that might not happen for decades.
And this foresight gets baked into a very simple, very powerful rule. Every single installation has to include a spare conduit that's just for maintenance. And get this, if an emergency forces them to use that spare for a new cable, they have exactly 2 weeks to clear another one to take its place. It's a non-negotiable part of future-proof.
Now that kind of long-term thinking leads us right into our next big idea. Rule number 2, safety above all. Because when you're building something to last for a century, you have to plan for every single invisible danger that might be lurking underground.
The standard is unbelievably specific about where you cannot put a manhole. We're talking about classified hazardous areas, oil refineries, anywhere near gas stations, landfills, and especially pipeline corridors. This is risk management on a massive, massive scale.
And the language they use, it's intense. The document literally shouts this warning in all caps. These things shall never, under any circumstances, pass through their manholes. The stakes are just incredibly high, and these rules leave absolutely no room for error.
And safety isn't just about where you build, it's baked into every single procedure. Before anyone can even step foot into a hole that's deeper than about 4 feet, the air has to be tested for hazardous gases or a lack of oxygen. It is a literal life-or-death checklist.
Okay, so this brings us to rule number 3, playing well with others. Seriously, think of the world right under our feet as this crowded, invisible city. And this document, it's kind of like the zoning law that keeps everything running smoothly.
And here are just a few of the super strict separation rules. Telecom conduits have to keep a specific distance from power lines to stop electrical arcing, they have to stay away from water mains to avoid contamination, and they have to maintain a minimum of 1 full meter from any oil and gas pipelines to prevent catastrophic damage.
And crossing a pipeline corridor, that's a whole procedure in and of itself. You have to go at least a meter below it, you have to encase the entire bank of conduits in concrete that stretches across the whole corridor. And you can't have any manholes within 25 meters. To say this is meticulous is a complete understatement.
All right, on to rule number 4, the physics of pulling. You'd probably think getting a cable through a pipe is pretty easy, right? Just tug on a rope. Well, as it turns out, it's a whole science. Let's talk about a key concept here, sidewall bearing pressure. Basically, when you pull a huge, heavy cable around a bend in a pipe, it pushes hard against that inside wall. If you push too hard, you can literally strip the cable's protective jacket or even crush it, making it totally useless before it's even switched on.
And yeah, there is a hard limit. That pressure cannot go over 150 pounds per foot. Any more than that, and you risk completely destroying the very infrastructure you're trying to install.
So, the engineers have to calculate everything. You've got friction inside the pipe, the number of bends, and by the way, you can't have more than 2 90-degree turns in one section, the radius of every single curve, and the overall tension on the cable. It is a complex physics problem for every single pull.
And this all brings us to our final rule, which is really the theme of this entire document. Rule number 5, details make the design. And this, my friends, is where we see obsessive engineering at its absolute finest.
Just take a look at this partial checklist for a single manhole. It needs special pulling-in irons cast right into the walls, a sump hole for drainage, galvanized steel ladders, a very specific copper bonding wire, and even a 30-inch locking iron cover that has to be stamped with the word telephone. Nothing is left to chance.
It gets even crazier. If any of the plastic conduit is exposed to sunlight, it has to be sanded down and given 2 coats of a specific water-based acrylic latex paint. And not just any paint. It has to be light orange or white with orange stripes. They even specify the paint.
This even extends to how you pour concrete. When you're encasing these conduits, the concrete pour must start from one end and work its way to the other. You are explicitly forbidden from starting at both ends and meeting in the middle. The very way you pour concrete is a rule.
So, after all that, what's the big takeaway? These aren't just random, arbitrary rules. What you're seeing is a century of trial and error, of accidents and breakthroughs, all boiled down into a guide for building a global network that works so well we never even have to think about it. It is literally designed to be invisible.
And really, it makes you wonder, what other hidden rule books are out there, quietly shaping the world that we live in every single day? That's all for this one. Thanks for diving in with me.